Welcome back to Machine Learning Guide. I'm your host, Tyler Ranelli. MLG teaches the fundamentals of machine learning and artificial intelligence. It covers intuition, models, math, languages, frameworks, and more. Where your other machine learning resources provide the trees, I provide the forest. Visual is the best primary learning modality, but audio is a great supplement during exercise, commute, and chores. Consider MLG your syllabus with highly curated resources for each episode's details at ocdevel.com/MLG. I'm also starting a new podcast which could use your support. It's called Lefnir's Life Hacks and teaches productivity-focused tips and tricks, some which could prove beneficial in your machine learning education journey. Find that at ocdevel.com/LLH. Welcome back to Machine Learning Applied. In this episode, I'm talking to Dirk from Depth Agency about Kubeflow, Kubeflow. It is an extension on Kubernetes for machine learning pipeline orchestration. In the last few episodes, we talked about SageMaker for accomplishing the same thing. And then in the DevOps episode, we talked about just general DevOps deployment of your web stack to the cloud. And if you'll recall, there are solutions for hosting web stacks in the cloud like AWS ECS, and then there's the open source equivalent to that called Kubernetes, and an AWS service called EKS, or Elastic Kubernetes Service, allows you to use Kubernetes on AWS. So you can either use ECS or EKS. ECS is going to be using AWS as a managed service for hosting your Docker containers, and so it's going to be easier to use. And EKS, or Elastic Kubernetes Service, is going to allow you to host your Kubernetes cluster on AWS. The benefit of Kubernetes is that it is open source and cross-platform. You can host your Kubernetes cluster on AWS, GCP, or Azure. Setting it up in those various providers is going to be a bit different. So it's not just a turnkey, one-size-fits-all, but it's going to be more cross-cloud provider compatible than if you had set up your cluster on ECS. So AWS ECS, their managed container hosting solution is easier, but there's vendor lock-in. And then EKS, their managed Kubernetes solution, is harder. It's more complex for certain, as you recall the discussion with Girowatt, but it is open source and it is general case, cross-cloud compatible, and you can use it on localhost or on-prem. And so the equivalent in the machine learning space is Amazon SageMaker for their hosted machine learning offerings versus Kubeflow, an extension on top of Kubernetes for the open source cross-cloud compatible version of the same. And before we get into this interview, I just want to talk about what these things are, these pipeline orchestration tools. Because SageMaker is not just about hosting a machine learning model. That's the tip of the iceberg. It's a very useful solution. If you want to get your machine learning model on the cloud, it is easier to use SageMaker's model endpoints or batch inference jobs than it is to try to spin up your own machine learning model hosted solution, even on ECS or EC2 or anything like that. So even just deploying your machine learning model via SageMaker is going to be a simpler solution than roll your own. But the main value of SageMaker is not just hosting your model, it's all the other stuff that comes as part of the package, what we call pipeline orchestration. So when you're training your model, you have your data. It comes from somewhere like AWS S3 or their relational database service RDS or DynamoDB or something, okay? And then that gets piped into a feature transformation step. And then that gets piped into the training step, the training phase of this pipeline. And that training phase might be splitting out your data or splitting out your compute instances into multiple instances so that the training can happen in parallel and then rejoin the progress downstream as the next step in the pipeline. Do some checks, some bias checks, some drift detection, and then deploy your model to the cloud. And then additionally, as part of these pipeline orchestration tools, there is a continuous monitoring aspect where if something goes wrong in the model pipeline, it might trigger a retraining job by reusing the entire pipeline from the beginning. Or let's say that new data comes in over time. The users have interacted with your website for a while. Let's say you have a matchmaking service for music or videos, and they thumbs up and thumbs down certain things. And so you want to retrain, not because anything went wrong, but because you're a little bit out of date. So these machine learning pipeline orchestration tools like SageMaker or Kubeflow are the end goal of creating a production-ready deployed machine learning end-to-end solution, not just the machine learning model in the cloud, but the entire process of what goes eventually into the trained and deployed inference model in the cloud. And so all those steps of the pipeline are important. And so everything we've talked about with SageMaker has these tools for stringing together steps of this pipeline orchestration. One will be ingesting the data, and one will be data engineering, so feature engineering and imputation and all that. Another will be training, including parallelization, and so on. And so that's SageMaker, which is AWS's hosted offering. It's easy to use, but you're locked into AWS. So today we're talking about Kubeflow, which is an extension on top of Kubernetes. It's the open source version of SageMaker, effectively. It is universal, so it can be hosted on all the different cloud providers. And again, per the discussion with Jirwat, the downside is going to be more complex to manage. So that's an introduction to the topic, and let's dive right in. All right, welcome back to the show, everybody. Today we have Dirk from Dept Proper. And Dirk, go ahead and introduce yourself.
Yeah, thank you, Tyler. Hi, my name is Dirk Jan, and I'm part of the Dutch data science team at Dept. I help my clients with building smart solutions to discover valuable insights in their data and to solve critical business challenges, both with machine learning as well as more like low-level data analysis. And I work a lot also on the machine learning engineering part, and that's also what we're going to talk about today.
Fantastic. In the past few episodes, we've been talking a lot of DevOps with a goal of achieving MLOps, getting your machine learning model into the cloud.
Mm-hmm.
And in this journey of MLOps, I've realized it's not just a matter of getting your model in the cloud as some REST endpoint, which SageMaker can accomplish very easily, but a lot of times there's a pipeline you want to build out. So you've got your training phase. It will periodically ingest the data, maybe shard that out to multiple nodes.
Mm-hmm.
That splits the data up, crunches it a certain way, brings it back together, pipes it through the machine learning model. And so there's all these different pipelining tools. I'm familiar with SageMaker. I've presented that on the show. Last episode, we talked a little bit about DevOps, a little bit about Kubernetes in DevOps. And today, your specialty, right, in MLOps is Kubeflow. Is that?
Yeah, that's totally right. And it completely touches upon Kubernetes as well, as it's basically a orchestrator for pipelines on Kubernetes.
So talk to us about pipelines in general.
Mm-hmm.
I have introduced the topic to my listeners, but I don't know that I've gone sufficiently down the motivating the entire process. And then eventually we'll get into like, what are the options out there and why Kubeflow?
Yeah.
So talk to us about pipelines.
Yeah, definitely. So the first thing that's good to know is often when you have like these examples, these toy examples of machine learning problems or any data problem, it's very much focused on the solution itself and training a model to predict something and then use that output to optimize business processes or decision making. However, what we see at our clients mainly is that a lot of our clients have different business problems for which we develop different models. But you get at a point where you have so many models in place that knowing how well a model is still performing and retraining that model is going to take a lot of time. And you basically can't just spend time on retraining and checking if a model is still properly working if there are also new use cases that you're working on for that client. So at that point, you're kind of forced to move away from standalone models and hop on machine learning pipeline train, because that really helps you to, first of all, keep track of the performance of the model. It helps you to automatically retrain models. And it just makes your life much more easier as it's taking a lot of time away and then keeping the quality of the models up.
It almost sounds like what continuous integration, continuous deployment, CI/CD is for the software world.
Mm-hmm.
Machine learning model or machine learning pipelines is for the machine learning deployment world. Does that sound like a good analogy?
Yeah, that's a perfect analogy. I think that if you look at what data science field in general, it's much more moving towards a continuous integration and a continuous deployment of models. Of course, like the big companies like Google and Facebook, they already do this for a long time. That's also why they now have these frameworks and these platforms that basically allow you as a data scientist or a machine learning engineer to do that as well. And they have invested already a lot of money in those solutions. But I think more like the smaller companies, especially in the beginning, it was more focused around building a model and solving a business solution. And sometimes it kind of lacked the continuous development and deployment and integration of like the machine learning solutions.
Got
And I think a lot of companies now start to realize that machine learning pipelines are just as important as building a model, because model without a proper pipeline behind it is eventually not gonna perform as well as when it was just developed, because data changes over time, especially now, for example, with COVID. So when you have these models that predict customer behavior or that take customer behavior into account to predict something else, especially with COVID, that retraining part is more important than ever because customer behavior really changed during that period. So you can imagine when you use a model that was trained on data before that period, that it's not going to perform as well as it was during like COVID or after COVID, because behavior totally changed.
So it keeps up. So these pipelines keep up with the times, with the change in data. Do you find yourself, I know that these frameworks, and what are we going to call these frameworks? Is it right to call them pipeline frameworks, or?
I think the proper term would be pipeline orchestrators.
Do you find yourself using these exclusively, or do you still do your model development on localhost, just in a Docker file, TensorFlow, whatever?
It kind of depends. So especially with clients that we work with already longer, we now move towards developing from a pipeline perspective. And of course, the development of the model and the testing of the model and the first version of evaluation of the model, that can still happen outside of that pipeline. But everything around it and the structure is basically set up to eventually be used for a pipeline kind of architecture. And then we also have these clients where we just started building solutions. And there sometimes we see that there's first a need to, see how machine learning or data science solutions can help improve their business. So you could say they're less mature. And then we often see that pipelines are not really the way to go yet, because we first need to really discover what data science and machine learning can bring for that client. But for long-term relationships and clients that are really mature, we really move towards developing from a pipeline perspective rather than a standalone model.
I like that. It's measure twice, cut once. You're kind of already in the mindset and platform developing towards the pipeline. And then when it's time for production, you're 10 steps ahead of the game. Sorry for all the diversion. Your expertise is in this area. So I'm going to just go ahead and let you drive and take us on a journey. Talk to us about Kubeflow and the various other options and all that stuff.
Yeah. So the reason I took Kubeflow is that because that's one of the main orchestrators, or one of the pipeline focused project that we at Dev chose to go with. And to maybe start off with like what really Kubeflow is, I already mentioned it before. Kubeflow is basically a solution that focuses to deploy a machine learning pipeline on a Kubernetes backend. And that helps to make the pipeline very scalable. Like that's one of course, the key benefits of Kubernetes, the scalability that you have. And also at the same time, Kubeflow integrates a lot of these different kind of frameworks within. So it allows you to either use TensorFlow or scikit-learn or PyTorch, and all of those modules or packages, how you like to call them, you can very easily incorporate those in a Kubeflow solution. And Kubeflow itself doesn't necessarily have to be a pipeline. Kubeflow also offers the possibility to basically submit a job on a Kubernetes cluster. So just like a training job or a data processing job. But it also at the same time allows you, using the Kubeflow pipelines architecture, to build full-on pipelines. And that really gives Kubeflow as a whole a lot of flexibility. Besides also it being open source. So a lot of people develop and contribute to the framework itself. And what you see, because it's open source, a lot of these challenges that we as a company deal with as well, other companies deal with those as well, of course. And because of that open source nature of Kubeflow, you see that development goes really fast. And every day there's like something new released, which might also solve one of your problems, which otherwise you would have had to spend quite some time on to solve it yourself.
In the last episode with Gigawatt, we were kind of comparing Kubeflow with AWS's ECS service, Elastic Container Service. And so we have the cloud native offerings, Microsoft Azure, Google Cloud Platform, and Amazon Web Services. In our episode, we recommended AWS, if nothing else but popularity sake. It's just like, if you want to find a job, you're probably most likely to find a job in the AWS marketplace because of its popularity. And in SageMaker land, the way they do pipelines is, there's a lot of overlap with Kubeflow's offerings, Kubernetes offerings. So SageMaker would probably be the equivalent of Kubeflow in cloud native on AWS. And then ECS is the equivalent of Kubernetes on AWS, a container orchestrator platform, but it's all closed source. We don't have visibility into how any of this stuff works. But by that standard, it would seem that Kubernetes and Kubeflow would be preferable. Why not get open source if you're going to be getting the same thing in the first place on AWS? And Gigawatt's statement was that Kubernetes is quite complex, a large pill to swallow from a developer's perspective compared to ECS.
Yeah.
And I wonder if that's similar to your own experience. And if so, how does Kubeflow compare in that analogy to cloud native machine learning offerings?
Yeah, so maybe the first good thing to know is, even though Kubeflow is originally built on Kubernetes, it's not just limited. So like in Google Cloud, because that's also a little bit of the history of how Kubeflow originated, and it comes from Google and how they internally deploy machine learning pipelines for all their services. And they built like this entire TensorFlow package around it called TFX, which we will touch upon later as well. But Kubeflow is not just limited to Kubernetes. And also at the same time, Kubeflow takes a lot of this complex deployment process that you have with Kubernetes, takes it away and does it for you. So especially as a machine learning engineer or a data scientist, you might not be very knowledgeable about Kubernetes or know the ins and outs of how to deploy something on Kubernetes. But Kubeflow really facilitates that for you and helps you with that. At the same time, Kubeflow can be deployed on most big platforms like AWS, Airflow, Azure, Google Cloud. And in Google Cloud, you even have the option to deploy it on Kubernetes, which it originated from, or more like a AI platform, what they now call like the Vertex AI platform. So I think, whereas when you focus, for example, on more like an AWS or just an Azure, you're very limited to that platform. With Kubeflow, you can reach across just one platform and have the possibility and opportunity to not just stick to one platform, but also deploy in other platforms if you need it. And of course, the setup process is going to be a little bit different, but a lot of the complex stuff that comes with it is handled by Kubeflow. And I think that makes a huge argument for using Kubeflow together with the open source nature that it has.
Yeah, and I think another great argument with it being cross-platform compatible is local host development. With SageMaker, one thing I come up against in developing with the cloud in mind, the benefit is that, again, that measure twice, cut once. You're already in the mindset of working with VPCs and security groups and IAM policies before you can even run your model. But on the downside, good luck with debugging and local development. If you need to be in a VPC, you're not really going to spin this up on your local PC. You're going to have to create a bastion host in the cloud or a client VPN that's able to connect to the VPC and all that stuff. So the complexity that Gigawatt and I discussed of Kubernetes in use case in general, that's one thing, but we're not accounting for many times the complexity of developing towards ECS when your development environment is localhost. So it seems like there's plenty of pros and cons on both fronts if we want to talk about the debate of complexity. And then do you guys use Kubernetes for the general DevOps stuff, for web hosting as well?
I think that kind of depends per client. I'm not really aware of that part, as I'm more like part of the data science team, so not really of the web and app development team. I know there are some deployments that happen on Kubernetes, but further than that, I'm really not sure how the DevOps or the development teams at depth tackle that part.
Your preferred cloud is GCP, is that correct?
I wouldn't say preferred. It's more like a lot of our clients work with that. I think in Europe in general, For a long time, Google has, together with Azure, has been one of the bigger cloud platforms. AWS is kind of taking over, I think, at the moment. But I think it's also because we're in the marketing business, or a lot of our clients, the solutions that we build for them are marketing related. And a lot of those clients work with Google products like Google Ads, Google Analytics, those kind of Google-based products. And that's also the reason why they often go for Google Cloud, because it's a logical decision to make if a lot of your other systems are also by Google, developed by Google.
That makes sense. And how about Azure?
We do see a lot of Azure, but what we do see is the clients that use Azure are often less marketing focused, as you might say. It's more like operational, business operations, financially focused solutions that we then build for them. Yeah, so for example, we have a client that's in the real estate development business, and we build more like operational solutions for them, and they are also on Azure.
That adds a lot to the puzzle. When I meet people who are trying to get started in the cloud and they say, which one should I pick? I always say AWS, just because it's most popular. So it's an easy answer. But I never have any real technical argument for any of the specific cloud providers to provide.
Yeah, I think if you're in the marketing business and you're using a lot of the Google products, it's one of the most logical steps to make. From a connectivity standpoint, of course, you can get the data from Google Analytics or Google Ads to any of the other platforms, but some of the integrations are much more straightforward with Google Cloud than with, for example, Analytics, Google Analytics, and AWS.
And then on Azure's front, if you're a Microsoft shop, it's a shoo-in. But then potentially, as you mentioned in finance, as an example, or operations, people in finance are so used to Excel. That's a Microsoft product. Seems like it's an easy step towards that platform if you're coming from an environment in which Microsoft products would have made sense on the desktop.
Yeah, definitely. And also, for example, a lot of the companies that are, for example, using Microsoft Dynamics or those kind of packages or those kind of softwares, that also would make sense to stay with a Microsoft related cloud. I know for some companies that aren't allowed to use Google. It's mainly a big thing in, I think, Switzerland. A lot of the companies there, they want to stay away from Google. So they're either on like their own custom or still on-prem or also on Azure. That could also be a reason.
Does GCP have its own version of SageMaker, its own non-Kubeflow based ML ops offering, possibly including pipeline orchestration?
Yeah, so since I think a couple of months now, Google Cloud used to have what they call like AI platform. That's where all your AI related stuff lived in. So your Jupyter notebooks, your job logs, your model endpoints, all that kind of stuff. And they recently changed that to something they call Vertex AI. And with that, they give some more possibility. Whereas AI platform before, you had like a pipeline option, but that pipeline option was mainly consisting out of a Kubeflow kind of pipeline. And it was based on Kubernetes, basically. What you had to do is spin up a Kubernetes cluster, deploy Kubeflow on that, and then you could build your models on that, for example, with TFX. And then when you would go to the pipeline section in AI platform, it would actually open up the UI, the interface of Kubeflow. Now with Vertex AI, they have a little bit of a different approach. You still can run Kubeflow on that, but you can also orchestrate your pipelines. It's still from within Kubeflow, but all the Kubernetes stuff is handled for you. So you don't have to spin up like a Kubernetes cluster or those kind of things. So it makes it a little bit more easier than the old way.
Is more managed.
Yeah.
Is it a rebranding? Are they migrating their original offerings to this new Vertex AI solution? Is it a rebranding or is it an alternative solution?
I think it's a little bit of both. So some of the stuff from AI platform right now, they're rebranding it and including it only within the new Vertex AI section and under the Vertex AI brand. But for example, the option for pipelines is still available in both AI platform as well as the Vertex platform. And also interfaces are different. If you go to the AI platform pipeline interface, you get basically the Kubeflow interface. However, when you go to the interface of pipelines in Vertex AI, you really get a dedicated Google Cloud pipeline interface that's really developed by Google and not necessarily by Kubeflow.
So potentially Vertex AI is the SageMaker equivalent on GCP, the managed machine learning offering.
Yeah.
Kubernetes was developed by Google for Google. Obviously, it's going to have first-class support on GCP. Kubeflow is developed by Google as well?
Yeah, it's developed by the TensorFlow team.
Okay.
Or not necessarily the TensorFlow team, but it's built around TensorFlow and TensorFlow pipelines to facilitate those.
TensorFlow pipelines. Okay. Yeah. What is TensorFlow pipelines? What is TFX? TensorFlow Extended.
Yeah, TensorFlow Extended. Yeah, TensorFlow Extended basically started within Google, and that runs, or originally run on Kubeflow. And I think Kubeflow is still the only option through which you can deploy TensorFlow Extended pipelines. And that was a kind of a way for Google to basically make pipelines for all their big services. So all the models that are behind Google Email or Google Calendar or Google Maps, like all these big services in which they have a lot of machine learning models running, they all needed a continuous deployment, of course, because these are huge services. And also it needed to be scalable, because you can imagine those services are used by millions of people. So that's how they developed, or as an internal service, they built what is now known as Kubeflow. And TensorFlow itself for a long time was just model building. So like deep learning models, machine learning models, probabilistic models. But with the extended package, it reaches further than just the model part. It basically takes up the entire part before building and training a model. So like cleaning up your data, transforming your data, checking for anomalies, creating a schema from your data, but even reading your data from, for example, BigQuery or a cloud bucket in Google Cloud. And also the part after the machine learning model. So the evaluation of the model, checking if the retrained version of a model is performing as well as the previous version. Because, for example, you can imagine that if you do continuous training for a model using those pipelines, that you can end up in a situation where you retrain your model, but the performance of it is not necessarily better than the previous version. So also that is something you have to take into account. And finally, of course, pushing your model to either an endpoint, a location in Google Cloud Storage, or creating a BigQuery model out of it. All those steps, they basically build modules within the TensorFlow package around that to facilitate those steps. And all those steps together create what they call a TFX pipeline, which is then deployed through Kubeflow.
What is, there sounds like there's a lot of overlap between TFX and Kubeflow. What are the differences between the two?
So basically, TensorFlow Extended is just the logic part. So how are you building up your model? How are you generating your schema? How are you transforming your model? How are you evaluating your model? And for that, they all made like these components, which they call like components. So you have like a trainer component, you have a evaluator component, a statistic generator component, and all these components form like a pipeline. And they are deployed on Kubernetes, for example, through Kubeflow. So basically the back end of that pipeline is Kubeflow, and that executes the TensorFlow extended code.
I see. And so if you're using Kubeflow, especially on GCP, you're also going to be using TensorFlow extended, very likely.
If you are working with a TensorFlow model, definitely, but you're not limited to. You could as well use PyTorch. You could use scikit-learn or any of the other major machine learning frameworks that are out there. But originally, it is developed around TensorFlow Extended because it was like an internal service at Google.
Is there any amount of TensorFlow Extended you could use if you're developing your model in PyTorch? Because it sounds like there's a lot of nice utilities in there.
Yeah, so then you get into the compatibility issues between PyTorch and TensorFlow. Like theoretically, you could definitely use those, but the way PyTorch is built up and TensorFlow is built up, theoretically they're the same, but technically they're sometimes quite different. I'm not sure if you ever tried, but try using both PyTorch and TensorFlow in your same machine learning code. It's going to be a lot of debugging, and in a lot of cases, you're going to end up using either one or the other.
Yeah. The podcast's kind of toy project is this journal app. And I do have to use both those frameworks in certain cases, just based on certain packages I'm making use of. And if I'm using both of them in the same, I actually kick off background jobs. So they're running on two separate Python memory space, because man, they duke it out in a Python script. They'll battle with each other.
Yeah, definitely. And also just like the types of how the outputs and inputs are defined in both packages are very similar, but it's sometimes like those little details that ruins the compatibility. I know there are like quite some cases where people do manage to combine the two, but it's a painstakingly process.
So let's look at where we're at. We have, if you want to get your machine learning model hosted, you have Azure, GCP, and AWS, and a whole bunch of others, but those are the main three. Each of those three allow you to do it yourself using open source tooling. That would be Kubernetes and Kubeflow. And they also allow you to do it through their offerings, which makes it a little bit easier, but you're locked into their offering. So those are called managed solutions. AWS is SageMaker, GCP's is Vertex AI. Yeah. And it sounds like there's a whole bunch of other open source offerings as well. We've got Airflow, MLflow, and what else are you familiar with? And to those that you can speak to, how do they compare to each other?
So what I'm familiar with is pretty limited to Airflow and Kubeflow and Google Cloud pipelines. I know a little bit about also Azure pipelines, not like practically, but more theoretically. What I like about the Kubeflow, sometimes like when I have these discussions with colleagues about this, and they work, for example, in Azure pipelines, they have a lot of these small issues, like authentication issues, compatibility issues, information being shared between different components. That's all handled by the combination of TFX and Kubeflow. So that's really why I prefer Kubeflow, but that's also, I might be quite biased because I use a lot of TensorFlow in what I do, in the solutions I build. And I just find the combination between TFX and Kubeflow to be very good. In the beginning, it's quite a painful process. It's like a very steep learning curve. You can get very frustrated during the process of trying to understand how they work together. And especially in the beginning, because I remember when I started working with the most recent version was 0.25, and we're now at version 1.4. And just a time frame of 6 months, the frameworks have improved so much that a lot of those like little issues have all been taken away. And you just see that there's a lot of dedicated time and effort spent on improving these services. And from what I've seen in, for example, Azure, is that sometimes it can take quite a while before some very basic issues or from which you would expect that they would be solved much quicker than what is actually happening. And regarding like Airflow, from what I've read and what I've seen so far.
And what is Airflow real quick?
Yeah, so Airflow is basically a orchestrator that works with like DAGs. And then I have to search for the official term.
DAGs, directed acyclical graphs.
Yeah.
Okay, so in a pipeline of data, each step can connect to each other step.
Yeah, basically that. But the thing with Airflow is that it's not resource heavy. Like when you deploy something on Kubernetes, the processing power and the resources that you can use on Kubernetes are quite big. Like it's scalable, it can take quite some heavy loads. However, the thing is with Airflow is that you basically, for all the computational heavy stuff, you have to submit, for example, a job to AI platform. So when you want to train your model on Kubeflow on Kubernetes, you can choose to submit a job to AI platform. But you can as well just train it on the back end of Kubeflow, which is Kubernetes. You can just train it on Kubernetes. With Airflow, you don't have that option because it's basically just an orchestrator that executes the different steps in your pipeline. But when you need something that's more resource heavy, you always have to have something like an AI platform to spin up a machine that can then take the heavy workloads, do the computations and the model training, and then sends back information.
I see. Okay, I think I understand. So Kubeflow is pipelining and model orchestration in Kubernetes with machine learning in mind.
Yeah.
And Airflow is just a general purpose, just a stepper.
Yeah.
And it just so happens you can put machine learning into that pipeline, sure, but you're just going to be using some machine learning toolkit or cloud offering like GCP's AI platform.
Yeah, you will never be able unless you have a very light model and very little data. But when we're talking about heavy models, machine learning, deep learning models, for example, that take in millions of rows of data, you always have to have something else than just Airflow, because otherwise it's not going to cut it.
Do you use Airflow? Does it have a place? If you're already using Kubernetes and Kubeflow, is there any reason you would ever use Airflow for anything?
So what we do at Dept is we do a lot of data engineering tasks on Airflow. So triggering the export of data from one location to another, the creation of tables, all that stuff that happens within another environment but still needs to be scheduled. We do that mainly through Airflow. And for that, it works very well, but just not for machine learning.
Okay, so I hope I'm right in this, in the AWS land of managed step pipeline orchestrations, there's a thing called step functions, AWS step functions, and you might have AWS lambdas. So you might have a series of just raw functions that feed into each other in a specific order and then branch out and then come back together.
Yeah.
So general purpose, it sounds like maybe Airflow is for that purpose.
Yeah, I think you could say so.
And then how about ML flow? Do you have any familiarization with that?
I have heard about MLflow, but I've never really worked with their services.
Eke at it to see if there's anything that really stands out. Maybe I'll see if I can get somebody here in the future to discuss that, because I do see ML flow coming up quite often.
Yeah, I have not really seen anyone within our team, at least, that uses MLflow.
Okay, that's good to know.
But maybe at Rocket?
Not that I've seen yet. So the main contenders that I have seen really in my world is you and me, Kubeflow and SageMaker.
It's a funny thing, actually. I'm going to work with SageMaker for Just Eat, which is Grubhub in US, right?
Yeah, like delivery. Oh, cool. Yeah. You know what I love? So for the listeners, a little bit of a tangent. So Dirk comes from Dept. Dept agency is the master organization. I actually working for a company called Rocket, which is a subsidiary. It was recently acquired. There's a lot of smaller companies within Dept agency. And so it's nice that Rocket's main skill set is AWS in the cloud offerings. And then Dept's main skill set is Azure and GCP. So we're the perfect match.
Yeah, together we basically cover the biggest share of cloud platforms, I guess.
Do you have anything else to say about Kubernetes, Kubeflow, TensorFlow Extended, or any of the other offerings?
Yeah, I think in general, we talked about the benefits of Kubeflow compared to all the other options that are out there. The most important thing is not really what you're going to use eventually, just discover your options and see what is out there and then what fits your purpose. Because in the end, all these solutions and options, they all serve certain purposes better than other. I can imagine that if you are completely set up in AWS, it wouldn't really make sense to go with something else than SageMaker, even though Kubeflow delivers these very cool solutions. And of course, you can still deploy Kubeflow in AWS, of course. I think the main lesson is to just move towards a more like pipeline, or to start thinking in machine learning pipelines rather than just standalone models. And then which platform serves the best, that's really up to your situation. Personally, I've always found Kubeflow and TFX to work very well together, and has served so far most of the needs of our clients. But I guess there are situations in which Kubeflow is also not going to cut it for you.
Yeah, I like the idea of starting to think towards orchestration instead of just, like you said, instead of just local host model development. Even in training, if you're going to train your own model, by quickly just starting on one of these platforms, your training job, you'll be able to shard it out to multiple nodes and potentially in the cloud, ideally in the cloud, so that you're not confined to your own local host GPUs limitations, or if you don't even have a GPU. I know a lot of people develop on Macs, and you can't do machine learning very well on Macs. And if that's your limitation, hey, you could just kick off a Kubeflow pipeline or a SageMaker pipeline, and it will distribute your data out. If you have a huge data set, it will train it on multiple nodes and then recombine the results downstream. And so your training jobs will go a lot faster. It doesn't have to be that expensive, because you can use on AWS, you can use what's called spot instances that are super cheap, a little bit less reliable, but super, super cheap. GCP has its own equivalent, right? What are those called?
Machine types, you mean, like the virtual machines, the workers that they spin up?
In AWS, these spot instances are actually, if there's like excess compute capacity from some, like one organization reserved some amount of compute, and then they just so happen to not be using it at that time, you can fill in that gap and you're paying substantially less for that compute, but your machine might get taken offline if that organization comes back. You're basically house sitting for them.
I'm not sure if Google Cloud has something like that because I haven't seen it before.
Preemptible instances.
That's the Google Cloud equivalent for that.
Yeah. Oh, you can save like 90%. So what I tell a lot of my friends who are doing machine learning, hey, but I have a Mac, I'll say, you know, use AWS, kick off a training job on a GPU based instance, but you use a spot instance and you can save 90%. I think that's the far end of the spectrum. So if an instance costs $1 per hour to run, like a G4 2x large costs like $1 to $1.40 per hour to run, 90% savings, it's, 14 cents per hour. It's a huge difference. But the downside is it can come offline. It's actually somewhat rare. You bid on it. You say, I'm willing to pay $2. If the price hikes and everybody else wants that house sitting job, I'm willing to like pay over the original cost, but you'll find yourself in that regime quite rarely. And so these spot instances are incredibly useful and valuable and not as unstable as they would seem at a glance. You wouldn't use these for like production grade things. You wouldn't use these for long running instances. It's phenomenal for training jobs.
So you would recommend them also to use it like already deployed and models that are running for clients? Because I can imagine that. So how we at that kind of build our stuff is that everything is dependent on one another. So the output of a model is going to be taken up by some other job to basically get the output to the location for when it then can be used. But with these spot instances, let's call them, how would that affect, for example, when your worker is taken away because it's utilized by the original organization? Is your job then just waiting until it's finished, or is it going to fail, or how is that then going to play out?
You definitely wouldn't use it in post training. This is only for the development phase or the training. Like, let's say your model drifts and you get some alert that it needs a retraining job, then you would use one of these spot instances. It depends on the framework being able to pick up where it left off. If the spot instance goes down, and I did look it up, so in GCP, it's called preemptible instances. If that goes down, it depends on TensorFlow being able to take snapshots and then pick up from where the last snapshot left off. It would then have to notify itself to try again, create a new spot instance, pick up where it left off before saying that the job is done to kick off the next step in the pipeline.
Yeah.
This is kind of the idea that you could do this instead of localhost development of your model training part. You can kick this off to the cloud using spot instances for cost savings and then steep yourself within the orchestration paradigm.
And that sounds indeed as a very good solution to against like training locally or paying full price for a machine. So yeah, what I always like to do is just train on a small subset of data just to debug, and then when everything is working, just submit the entire data set to the model within the pipeline. And so far that's been working pretty good, but I guess this would also be quite a good solution to cut down costs.
Just for fun, what's your development environment? Are you PC, Linux?
I'm both. So when I'm at home, I use Windows, PC. Yeah, I don't use Linux. And then at work would also be PC, but Mac, but no Linux. I've tried it like at university once, but I don't know. My focus is more towards like model building and theoretical data science. I found all the hassle that goes into setting up Linux in the proper way. I didn't really enjoy it that much. So.
Definitely a maker's thing, tinkerer's job. I remember growing up in the early days of Linux, it was a war between all the distributions and the flavors, and everybody was trying to find the best. And there was Ubuntu on the easy side, on like the managed Linux front, and it was Gentoo on the other side. And those two were the extremes. And I'm like, why would anybody go Gentoo? But there are makers out there. There are people who like to fiddle.
Yeah, so I know like the old data engineer was like the team lead, Jasper. Did you read him?
Yeah.
He would use Linux at home.
I use Linux quite often. I use all three. I use Mac, Windows, and Linux. Windows for gaming, Linux for model development and all that stuff. But increasingly, I'm trying to do a lot of my development in the cloud. cloud first. I would like to ask if you could take us through a project beginning to end journey. The beginning being, I know I want to build, let's say, an image classifier.
Yeah.
And the end being, I want that hosted online. How would we decide which cloud provider to use, or if we should use open source tooling? And what does the training process look like within the tools that you would end up selecting? What is the pipeline? Why the pipeline? And then how do we get that thing online and integrated into our website?
So from like a project at a client, or more like a general personal project?
Let's say our listeners, they land a client says, look, I know I need a recommender system or a image classifier. Or even as an alternative, the client may also come with their own specific environment. Maybe they're a Microsoft shop, or they're already using Google for their analytics. So like various forks in the roads during this process about why our machine learning engineer might choose one solution over another. And then as you go through those steps, you just say, but as we're going along, I'm choosing Kubeflow. Does that make sense?
Yeah, for sure. Yeah. So I think, and the first step, and that's not really even data science related, but the first step would really be to go back to the drawing table and have a look at their data to really see if what they want or what they request is also what they need. What we often see is that clients come with a directed question and already some sort of an idea what they want. However, because what we always do first, we start with the process that's called data discovery. So we see what systems are in place. How are these systems connected? What data do we have? What do we see from the data? So like a small version of an EDA. Can we even support that solution or questions that they have with the current data that is in place? So that would really be I would even call it step 0. Go back to the drawing table, see if the question that the client has is really what they also need. Because for a very, very nice example is to stick to like recommender systems. We had a client that came to us with the question like, yeah, we want to have a recommender system on their website. And when we started looking into their data and investigating customer behavior and through all the systems they already had in place, we actually discovered that they needed a better search function. So they didn't need a recommender on their website. They needed a way for people who visited the website to find products more easily. Because what we already could see from like the first discovery phase is that it was very hard for people to search for products, because often the products wouldn't really show up when they search for it. So that really would be step 0.
Just Elasticsearch, or you implemented some?
So the client went with a tool, which I forgot the name from. I think it's something called like Seeker, but I'm not sure. So yeah, that's now where we're at. But okay, let's say the client comes with a question and that is a valid question, and that's a valid problem that we can solve in the way that they see it. After we have done the data discovery, we see that the right systems are in place, or some systems still need to be implemented for everything to work well. We always first look with, okay, is there already a platform that they are working on? A lot of the clients that come to us are bigger clients that already have a cloud platform, either AWS, Google Cloud, or Azure. But in case they don't have such a thing, we look at what their services are that they already use and which cloud platform might be integrated with those other services most easily. So in case of like what I said in the beginning, if it's a company that uses a lot of Google products, then a logical recommendation would be to start using Google Cloud. But on the other side, if they already use a lot of Microsoft related products, Azure would be a recommendation. So that would then be step 1, setting up their cloud environment. And then step 2 would be for the data engineers to make sure that all the data is in place and everything is available. But also this depends, of course, on the use case, because there's a little bit of a separation in approach. Because in some of the cases, what we start doing is first see, okay, the client wants to see if the output of a certain analysis or model is even going to help them improving their decision making. And in some cases, they really want to have a continuous deployment and use of output from the model. So in the first case, we say, okay, we first start with developing a model, validating the output, and then merging that to the cloud platform and deploying it on there. But it more happens that the client is like, okay, I want this eventually to live within my cloud platform. And then we start developing this together with the data engineers. We first make sure that all the data is in place, that all the data is clean, because that's one of the most important things in this like entire process. You have to have clean data. Otherwise, you're not really going to get anywhere with the outcome of your model.
Are we cleaning data yet in your journey, or are we just looking at the data to see if it's clean?
So in this case, cleaning, I think there are multiple steps in cleaning. There is already like a pre-selection. So if there's any faulty data that we already know when integrating or getting all the data together, making sure that that data is excluded from a data set that's finally going to be used by the data scientists to build their solutions on is, in my opinion, quite the right thing to do. Because when you already know that it's faulty data, then there is not really any reason to include it unless there's like a very specific use case, of course. So there is already like a pre-selection in that process. But then once all the data is in place, and this is also, of course, a iterative process that goes back and forth between the third step, which is the data scientist exploring the data and doing some EDA to see, okay, what do I already see as in statistics and visualizations from what I can see in the data, and he goes back to the data engineer because maybe for some of the data, a lot of values are missing or don't make sense or not in the right format. So like step 2 and 3 are kind of like an iterative process. So when step 2 and 3 are finished, that's when we start developing the model. So transforming your data for the right input. What we often like to do is we take multiple model approaches. So we have like a baseline model. So let's say it's a classification problem. We take like a random forest tree, like a random forest classification model, which is very easy to implement, but already can give you the first results. Then from that, we see, okay, where is it performing well? Where is it not performing well? Maybe we need to change some stuff in the data. So we go back to step 3 and 2 again. But then also from there, we start to maybe develop a more advanced model. If, for example, that base model is not where you want to have it. So then when we get more to the stage of developing that advanced model, then we also get into the stage of making sure that the model can be deployed. And if we want to build a pipeline around it, make sure that all the components that are going to be in place around the model itself are being built up and interact well with the part on the data engineering side. So it's kind of like a parallel process. We both develop the custom model or the advanced model, and at the same time around it, we build the pipe. And then when we have evaluated the custom model and it's performing well and the output makes sense, we make sure that the entire pipeline is deployed so that then the data engineer can also use the output or the model trained by the pipeline to predict on new data, which then can be used for any activation purposes that were determined in like the discovery phase. So that's kind of like the process that we walk through with a lot of our clients, but definitely not all of the clients.
And then how do you decide at that pipeline phase between, let's say, if you're on GCP, Vertex AI versus Kubeflow?
Yeah, so currently that depends a little bit on the framework that you're using, because currently when you use TensorFlow Extended, even like TensorFlow itself, they say that it's for now better to still use the Kubeflow, like the Kubernetes cluster implementation, so the AI platform implementation, because the Vertex AI implementation is quite new still and might not be as stable as the AI platform implementation. So for now, whenever we deploy such a pipeline, it's still an AI platform. But eventually, it will depend on if there are any client-specific requirements that might not be met by either AI platform or Vertex AI, or AI platform pipelines totally disappear and get merged within Vertex AI, of course.
Mm-hmm. Oh, man, so many solutions. I guess, in web development, there's a million and one frameworks as well. There's Express, Fastify, Fast API, and all those things. That's par for the course. Sometimes it makes selecting tool sets to become an expert in, stick with it is a little bit difficult. But this sounds incredibly powerful and popular too, Kubeflow.
Yeah.
It's one that definitely keeps coming up. It's almost, it boils down to me. So I do a lot of SageMaker work. oftentimes I reconsider. Should I just start learning Kubeflow? And, there are a lot of issues that I face and whatnot.
Yeah, I think that's also kind of the nature of Dept. We work with a lot of different clients. So we don't really have the luxury, let's call it that we can stick with one platform.
You have to know them all. Yeah.
Yeah. And one of the fastest ways to connect with other platforms with limited knowledge or not knowing all the dedicated pipeline orchestrations from each different platforms is using Kubeflow, because they can connect to all those different platforms. And of course, in some cases, it might be better to use the dedicated solution of a platform. But I think especially when you are in the business of Dept, where you have a lot of different clients, a lot of different platforms to work with, finding a solution that expands across those platforms and is not dependent on just one platform, that really helps us to deliver value to all our clients. And it makes us also much more flexible in the solutions that we can build and the clients for which we can solve their problems.
That is a really powerful deciding point right there. We're an agency. We have lots of clients. If you're in the same boat, it probably pays to go Kubernetes Kubeflow because it's a generalized solution.
Yeah, I really think so. And of course, you can also take the route of having different people with different expertises, of course. But from what I've seen and what I've found, if there's just a couple of people that do one thing, you will never get as good as when everyone works on like the same thing and then can basically improve themselves, but also the team. You make progress much faster than when there's just one person focusing on one solution and another person focusing on another solution. Then the knowledge sharing is also way less. And I think with Kubeflow, someone who works for a client that has AWS can use Kubeflow, but another colleague who works with a client on Google Cloud can also use Kubeflow. And still, in some way, they can share their knowledge with one another, which is going to be harder between someone who's dedicated to SageMaker and someone who's dedicated to Azure pipelines, for example.
Definitely. This is super valuable. I really appreciate this. Is there anything else you want to say about Kubeflow, TensorFlow Extended, or anything else?
No, I think what we just talked about sums it up pretty nice. Like Kubeflow is a flexible solution that serves most of the platforms, and not just the orchestration platforms, but also the machine learning frameworks. But also in the end, it comes down to what works best for you. But I think for us as an agency, the biggest point is that we have a lot of different clients. Kubeflow is really something that I think any agency that works with machine learning engineering and machine learning pipelines should consider using.
I like to end these interview episodes per the way Ship It handles theirs with a pick, I call it. Incidentally, you seem like a really interesting guy. This is going to be an audio format, but he seems like a really fun, relaxed character. So I want to get to know you a little bit. Tell me some of your interests or things you like to do off the clock.
Oh, I developed quite a lot of new hobbies during COVID and the lockdown. So first of all, I'm a big keyboard nerd.
Okay, you build keyboards.
Yeah, I build custom keyboards. So I got into that hobby actually during COVID, and it's like a rabbit hole. Once you get in, you don't get out. So I think that's one of my most recent private hobbies, as you could say it. I'm very interested in playing table tennis, which I also recently picked up again as a sport. So I guess that's basically my private interests. And I recently finished my master's degrees in data science, but always have been working on the side as a data scientist at marketing companies, before Dept at another company, and since 2 years now at Dept. So yeah, besides it just being my work, it's also my private interest. So during my time off from work, I also just like to read research papers, see what are new developments, what is out there, what are the latest trends on machine learning and its applications. So yeah, I think that both sums up my private and my work interests.
On the topic of a master's degree, this is something that a lot of my listeners are very interested in. And since it's so fresh to you, maybe you might have some insight here. Mm-hmm. They want to know, what amount of added value does a master's add over a bachelor's to finding a job in data science?
That's actually a good question. I see this often popping up on Reddit as well. A lot of people are asking this question. And I think it really depends on your situation. So take, for example, someone who comes from computer science or from a statistic background or from a mathematical background. If you want to get into the data science field, and you have a bachelor in one of those three subjects, like computer science, mathematics, and statistics. Personally, I don't think a master degree is in data science specifically is then going to serve much value for you, because in data science, the most important part is understanding the mathematics behind it. And the technical part, I think, is easier in some cases, is easier to learn than the mathematical and statistical part. So I would say if you come from a background where you have had a lot of mathematics, statistics, and I think with computer science, you have that same thing. You basically have a combination between mathematics and technical subjects. I think in those cases, a master degree in data science is not going to really add much value, or at least it's not going to add more value than when you start exploring data science yourself. And that's also what I see around me. A lot of people in the data science field are not necessarily people who did a master degree, but they had some technical or mathematical background, and they were interested in data science, and they just read papers and did courses on coding themselves. I think at that point, with such a background, a master degree is not going to add more value than self-study. However, like my bachelor's was more like business and economics focused. Of course, I already had an interest in data, and I tried to always combine what I learned in my bachelor's with like the data field, but it didn't really go further than like economical mathematics and statistics and business mathematics and statistics. And for me, it really helped to basically crank up my technical knowledge as well as my more specific data science, mathematical related knowledge. So I think if you come from a background that's like business related, I think it really helps to have a master degree in data science if that's where you want to go to. And then ultimately you end up with this perfect combination between understanding the business side and the data side.
One of those three, you said computer science. Let's say computer science, statistics, or math. And then let's say the third option is machine learning or data science as an actual master's degree.
Yeah.
Which of those three would you pick if your intent is data science or machine learning? It sounds like obviously C is the right answer, but it doesn't seem like that's necessarily so. If you had to pick a master's for data science, machine learning, would you go computer science, math, stats, or data science ML?
Personally, I think I would choose for stats or mathematics.
I think so. I think this is what the conclusion is coming to, even though it's almost like machine learning and data science. You don't know what might come next as the equivalent of that field in the future.
Yeah.
But there's old faithful all the time, which is stats.
That's true. And I think in the end, like you understand the solutions that you build the best and how it works if you know the stats and the mathematics behind it. And what I feel with sometimes these, from what I've seen, and of course this depends per university, but what I've seen from like these data science bachelors, it might sound like they're very related to the subject, but sometimes I think they stay too broad. So they don't really touch upon like the deeper mathematics and statistics behind it. And of course, in the end, it also comes down what subjects you choose, like the selectives that you have during your bachelor's and your master's, which can also really change with what kind of knowledge you finished those degrees. But I think statistics would definitely be the best backbone to have when going into the data science field.
I agree. And I've seen a lot of agreement on that front as well online. And then in universities, one thing I recommended a long time ago, and I don't really stand by it anymore just because I haven't kept up with it. So I'm kind of a blank slate on this front. It was OMSCS Georgia Tech online master's degree. It was really inexpensive, like $5,000 or $8,000 or something for a master's degree. Accelerated program. It was like 1 to 2 years master's, all online. And so it was a really attractive option as opposed to going physically back to university. I guess it's COVID now, so everybody's online anyway.
Yeah.
Do you find that those Udacity nano degrees, those aren't really going to get you much in the way of credibility in the job market? And then there's like traditional university for your master's degree, but there seems to be something of a middle ground these days with degrees offered online, maybe by well-known universities, but seem to be, I don't know if they're like an accelerated program or
Yeah, so I've seen them coming by like advertisements for those kind of degrees a lot, especially on platforms like Reddit. And from as far as I know, like you have to be very careful with the curriculum, because a lot of those online degrees, they seem very attractive because of their prices. However, what you really have to look out for is that it's not gonna be. So what I've read from it is that a lot of time people took those courses, they had barely any interaction with professors or other students. And personally, I think besides the courses itself, what I found very valuable, or during my master's degree, even though 50% of my master's degree was during lockdown, so I also couldn't go to university physically. And that's also why I realized that even more is the interaction between you and another student is as much as important as the courses itself, because everyone there has a different background and you can really learn from one another. I've had a lot of these group projects and meetings with other students during which I learned so much new stuff that I didn't even get in the courses itself, just because they were, for example, from a computer science background or from a mathematical background. I think, and that's a huge component that you miss when you take these online degrees. On the other hand, I have seen some very good ones that offer courses from very credible professors. I know, for example, that, and that's even totally free, but I think they also have like a paid version. MIT is publishing also a lot of these deep learning lectures. And if I compare those to the lectures that I got regarding deep learning in my university, is that the content there is pretty much the same. The only thing you're missing out on is like the interaction with maybe other students and a professor and the practical exercises that you get. So what I would advise is to really dig deep into what the curriculum has to offer and who are the people behind it. And also just check sources like Reddit or any forums, because there are a lot of people that shared their opinion about these kind of online degrees, but often it's really a hit or miss. So sometimes they're completely nonsense and you're not really learning anything, which you wouldn't have learned when you just watched videos on YouTube. And sometimes there are those that are really good. And I think that really also depends on the organization that's behind it.
I'm glad I asked you those questions. You have quite some insight on the topic.
Yeah, because it's a huge discussion that's going on Reddit, for example, as well. Like a lot of people asking, do I even need a master degree? And I found this online version or this online degree. Is it really necessary or valuable for me to further my career? I think there's actually a lot of discussion going on about these, and I always try to like kind of keep up with those things, because I find it quite interesting to see where those developments are going, because especially in the field of data science in education, it's changing very fast, and curriculums also from like universities themselves are changing every 2 years.
Yeah, another vote for math. It's like, are you going to learn TensorFlow and PyTorch or deep learning in, university? Who knows what comes next?
Yeah, because I remember like during my master degree, like the focus was a lot of like on machine learning and deep learning, but it's now already kind of shifting to more like reinforcement learning, because that is kind of the next step. And not necessarily the next step, but it's a level up, like more advanced. And you already see that there's a shift going on to push more also for those kind of subjects.
This was a wonderful, wonderful interview. I'm so glad we had it.
Really enjoyed it too. Thank you.